Good morning. Let me start by saying a few words about my company. You may not have heard of it. Airspan is a specialist fixed wireless access company. It was formed in 1992. Our main facilities are here in the UK. We mainly concentrate on frequency bands below the 10 gigahertz space. We currently have something like 130 networks in 60 countries, just to let you know. We've got a pretty packed agenda for my talk here. I wanted to quickly summarize the scene concerning the licensed and unlicensed bands in the UK. After Joe's speech, no need to do that, so I'll skip through that very quickly. I'll have a quick look at the technologies for broadband wireless access, then look at the applications, talk about the architectures, a very short introduction to the business case for broadband wireless access. I'll give you a couple of examples actually from around the world, one from Norway, the other one from New Zealand, very, very different examples, and finally a conclusion. Joe did a brilliant job covering all these items, and I'm really relieved to see that what he said and what I had on this slide are more or less in line. So thank you for that, Joe. I'll basically concentrate on the unlicensed bands and say a few words on those, because clearly there are more issues to consider when you are deploying systems in the unlicensed bands due to interference issues. So let's look at the technologies. This is an important message before I skip that. It wasn't mentioned earlier on. RA estimates at the moment that broadband wireless access will deliver something in the region of 7 to 18% of the broadband needs in the UK, which is a very encouraging, very important message. If we look at the technology issues, clearly in the unlicensed band, immunity to interference is a key concern. Particularly with the explosive growth in the Wi-Fi or 802.11 technology recently, there is considerable concern about interference in delivering public service in this space. The 802.11 systems have not been designed to combat interference because they were developed to operate in a controlled RF environment. So when we take that technology outdoors, there are many issues concerned with interference coming from other 802.11 systems as well as proprietary systems deployed in their frequency. We in Airspan, we have a product in this space. It uses the frequency hopping technology, which we believe to be the appropriate technology for this, for the unlicensed band, for the reason that the product can detect those channels where there are interferences and omit the use of those channels throughout the duration of the interference. Therefore, that sort of technology lends itself to be used in wide area outdoor deployments. Another issue in terms of broadband services is the delivered service quality. There's a lot of talk about the headline bit rates of 54 megabits or 11 megabits or any other bit rate, in fact. That does not say a lot in terms of the service experience of the end user. Many of the early deployed systems have been best effort systems. And this best effort system is no longer attractive to the consumers. The consumer wants to know that they are actually getting the service that they are paying for. In order to achieve this, the radio systems need to deliver quality of service, which is essential if you want to be able to deliver different service types. And also you need to have features such as committed information rate, a guaranteed rate that you'll be delivering to the customer, a maximum information rate, which is a rate that you aspire to deliver if there is capacity. And the good news for the operators is that if you have these features, you can differentiate your services and you can bill for these services in a differentiated way. So the message is we have to have software features such as committed information rate, maximum information rate, and quality of service, and not settle for just best effort. Okay, if we have the technology, what can we do with it? There are so many applications that can benefit from the broadband technology. It goes way beyond delivering high-speed internet access or delivering voice over IP. There are so many more applications that can be done. And I, for one, believe that the wireless ISPs and the wireless application service providers will be a key force behind bringing these new services to the rural communities. I don't have time to go through each and every one of them. Be happy to talk about them outside. But let me pick one or two examples. Cctv surveillance is a very important application, particularly in rural areas. So far, not very widely deployed because of the cost implications. We believe that coupled with wireless access, it is a much better proposition for quick deployment. Broadband in marinas and campsites is entirely possible with today's technology. You can arrive at the campsite, hire a radio unit, and enjoy broadband access, probably at the same speeds, if not better speeds, than you would get at home. Another application could be sitting at your desk through the web, remotely monitoring how your kid is doing in the kindergarten. There are so many applications. And as the technology gets introduced, we believe that these applications will enhance people's lives. Let's look at the architecture very, very simply. I've got 2 or 3 key messages to give here. This is simply showing a point-to-multipoint deployment. The end users on the right, a base station serving them. The base station is linked to the core network using a point-to-point radio link. And then you are connected to your internet and to your voice services. What is key here, a very important aspect, is the modularity of the architecture. A modular architecture will enable that you minimize your investment in the infrastructure. It gives you pay-as-you-grow capability and reduces the whole risk of bringing the broadband service to the rural community. Another important aspect is to make sure that the product range is able to support multiple frequency bands. Why is this important? Because it's entirely possible that we may decide to use a 5.8 gigahertz band for providing the point-to-multipoint system, and you may decide to use 2.4 for backhauling that towards the core network. If the same product provides both capabilities, they can be managed from the same network management system, making the whole operation that much slicker and easier. Let me say a few words about Airstan's product range that fits into this picture. I'll go through this very, very quickly. In the point-to-multipoint space, we've got 3 products today, starting from our Whipple product, which covers the data rates from 128 kilobits up to 4 megabits, and our product range takes us all the way up to 45 megabits, in fact. Our Whipple product is IP-based, completely IP-centric product, and it is ideal for the internet world. Our 4020 product, in the middle, is probably the world's leading product today, which is designed for delivering wireline quality voice with extremely low delay, as well as very high data rates. And at the top of the picture, we've got our 4030 product, which is predominantly for enterprise applications for delivering up to 45 megabits. In addition to our point-to-multipoint products, we also support point-to-point products for backhaul applications or campus applications. At the bottom, we've got our AS3010 product, which delivers up to 4 megabits point-to-point. Its main characteristics are covers a number of different frequencies, and it is extremely cost-effective compared to PDH solutions. And at the top of the range, we've got our 3030 product, which can deliver data rates again of up to 45 megabits. So that's all the plug, no more. Today, coincident with the conference, we are launching what we call Whipple in a Box. This is designed to make the whole experience of starting to deploy broadband in rural communities cost effectively. So what is in the box? There's a 4 megabit base station with omni coverage, 50 CPEs, and all the necessary network management system to get the whole broadband offering up and running. With a 10-to-1 oversubscription ratio, which is well accepted in the industry, this is going to enable you to be able to deliver up to 640 kilobits to the end user, which is very comparable to the ADSL rates. If we take this offering and put it into a business model with £35 per month monthly payments, the return on investment on the equipment is less than a year. And if we put together a complete business case and look at backhaul costs, the POP charges, taking into account £100 one-off installation fee, the whole enterprise goes cash positive in the second half of year 2. Important things is that we in airspan have got the technical and financial modeling tools available, and we are happy to work with you in order to put together the business cases for such deployment. Now I'm going to very quickly look at the 2 rural deployment examples. The first example comes from a company called Ino in Norway. Ino and BKK are the 2 companies that we are working with. As you'll see from the slide, Ino is a very small company. They've got only 11 employees, and they were set up with the express objective of bringing broadband to the rural communities in Norway. The way they do that is they created a technology model based around our Whipple product. They go to a village where there is no broadband, and they find a local partner, and together with the local partner, they offer the solution to the consumers in that area. This model has worked very well. Let me show you 1 or 2 pictures. The base station is on top of that building there. As we get closer, you'll see it. You can see 2 base station radios providing about 180-degree coverage, and people in their homes use the CP equipment to access broadband services through that base station. BKK is a larger company. It's a power utility. They've got their own fiber backbone, and they are using our technology together with other wireline technologies in order to deliver broadband in Bergen, which is one of the larger conurbations in Norway. So far, this particular operation has got 170 base stations and 1,400 subscriber premises equipment, operating both in unlicensed and licensed bands. I think something went wrong when we transposed the slides from one computer to the other. But the purpose of this is to give the following message. You might just about see the sort of values the businesses are paying for the broadband services to Ino. A 2-line business has got an installation fee of £325 and a monthly rental of £88. And this goes all the way up to monthly fees of £292 and an installation fee of £1,000 for a 25-line business. The message here is that the businesses, rural businesses in Norway, are prepared to pay these sums in order to take advantage of the competitive benefit offered by broadband. Second example, very, very different example, comes from New Zealand. BCL, Broadcast Communications Limited, is responsible for the broadcast infrastructure in New Zealand. Some time ago, they took the decision to also introduce broadband wireless access and use their existing infrastructure like towers to deploy this technology. They chose to use our AS4020 product. The aim is to put the infrastructure in place in the rural areas and then wholesale this capability to the operators like Telecom New Zealand, like Telstra Clear in New Zealand. So BCL does not sell the services directly to the end user, but they wholesale through the New Zealand service providers. And the objective is to offer the same service in the rural areas that you would get in Auckland and other major conurbations. Initial order for this project is 28 base station sites and 2,500 customer equipment. To conclude, we agree with RA that BWA will make a significant contribution to achieving the government's targets to make UK a competitive place or the most competitive market in G7. The bands are there, and as we heard before, more work needs to be done, but the infrastructure is there. There are significant advantages in deploying wireless, particularly in rural areas, due to speed of deployment and scalability. Airspan is a UK-based company with worldwide experience, and we'll be very happy to support the broadband initiative here in the UK. My colleagues, Jorge Rachowski and Paul Trubis, they are here. Outside in the lobby, we've got a stand. We'll be very, very happy to see you during the breaks at our stand, and we'll be very happy to talk to you. Thanks very much.